Look at this code carefully. Const user1 equals object, name, Alex, address, object, city, Colombo. Const user2 equals object, spread user1. User2.name equals John. User2.address.city equals Candy. Console.log user1. What do you think user1 will contain? Many people expect only user2 to change, but the output is object, name, Alex, address, object, city, Candy. Wait, we changed user2.address.city, but user1.address.city also changed. Why? This happens because the spread operator creates a shallow copy, not a deep copy. Before understanding shallow copy and deep copy, we need to understand the difference between primitive values and reference values. Primitive values include string, number, boolean, null, undefined, big int, symbol. For example, let A equals 10. Let B equals A. B equals 20. Console.log A, 10. Console.log B, 20. Here, changing B does not affect A because primitive values are copied by value. Now look at an object. Const object1 equals object, name, Alex. Const object2 equals object1. Object2.name equals John. Console.log object1.name, John. Here, object1 and object2 point to the same object in memory. We did not create a new object. We only copied the reference. What is a shallow copy? A shallow copy creates a new outer object or array, but nested objects are still shared. Example, const original equals object, name, Alex, address, object, city, Colombo. Const copy equals object, spread original.
Now, copy is a new object, so if we change the first level property, copy.name equals John. Console.log original.name, Alex. Console.log copy.name, John. That works as expected. But the nested object is still shared. Copy.address.city equals Candy. Console.log original.address.city, Candy. Console.log copy.address.city, Candy. So the outer object was copied, but address still points to the same nested object. These are common ways to create shallow copies in JavaScript. For objects, const copy1 equals curly braces ... original. Const copy2 equals object.assign empty curly braces, comma original. For arrays, const numbers equals square bracket 1, 2, 3. Const copy1 equals square bracket ... numbers square bracket close. Const copy2 equals numbers.slice. Const copy3 equals array.from numbers. These are useful, but remember, if the object or array contains nested objects, those nested objects are still shared. Shallow copy array example. Let's see this with an array. Const users equals square bracket curly braces name : Alex, close curly braces, comma, curly braces name : John, close curly braces, square bracket close. Const copied users equals square bracket ... numbers square bracket close. Copied users 0.name equals Sarah. Console.log users 0.name, Sarah. The array itself was copied, but the objects inside the array were not deeply copied. This is a very common source of bugs in React applications. What is a deep copy? A deep copy creates a completely independent copy of the original value, including nested objects and arrays. So if we deep copy this object, const original equals curly braces name colon Alex, comma, address colon city, Colombo, close curly braces, and then change the copied object. Copy.address.city equals candy. The original object should still remain unchanged.
Deep copy using structured clone. The modern built-in way to deep copy many JavaScript values is structured clone. Const original equals name, Alex, address, city, Colombo. Const copy equals structured clone original. Copy.address.city equals candy. Console.log original.address.city, Colombo. Console.log copy.address.city, candy. This gives us a real deep copy for many common data structures. It can also handle things like arrays, nested objects, dates, maps, sets, and more. But it does not clone functions or DOM nodes. JSON method and its problems. You may also see this older method. Const copy equals JSON.parse, JSON.stringify, original. This can work for simple objects, but it has important limitations. For example, const original equals name, Alex, created at equals new date, say hello equals function, console.log hello, value equals undefined, const copy equals JSON.parse, JSON.stringify, original, console.log copy. The function is removed. Undefined is removed. The date becomes a string. So this method is not safe for all cases. Practical React example. Now let's connect this to a real-world React-style example. Const state equals user, name Alex, settings theme dark. Const new state equals spread state. New state.user.settings.theme equals light. Console.log state.user.settings.theme. Light. This is dangerous because we accidentally changed the old state too. A safer update would copy each level that needs to change. Const new state equals spread state, user, spread user, settings, spread user, settings, theme light. Now the nested object is also copied properly. When should you use shallow copy or deep copy? Use shallow copy when your data is flat or when you only need to update the first level. Use deep copy when you need a fully independent copy of nested data. But also be careful. Deep copying large objects can be expensive. In real applications, especially with React or Redux, it is often better to update only the specific nested path you need, instead of deep copying everything. Recap. 1. Objects and arrays are copied by reference. 2. Spread operator creates a shallow copy. 3. Shallow copy copies only the first level. 4. Nested objects remain shared. 5. Deep copy creates independent nested structures. 6. Structured clone is the modern built-in option for many deep copy cases. 7. JSON.stringify parse has limitations. Here's a challenge. What will this print? Const A equals x equals 1, y equals z equals 2. Const B equals ... A. b.y.z equals 99. Console log a.y.z. Comment your answer, and in the next video, we'll look at another real-world JavaScript concept,